gonna go to update. Update done. Push that in there, click it in. So you just take this, plug it in. It basically charges the battery from the bigger battery, about 400 volts down to 12 volts. These grounds are used as positive. Zombieverter. So now we just need to pull up a wiring diagram and slowly figure out which pins go to what. Right here, this is the battery plug. So that guy, instead of having to do the jumper cables to the pins, we can just plug this in and take these wires out. Okay, there we go.
So you got that whole thing all disconnected perfectly.
Yeah.
And your schematics talk about the grounds, right?
Yeah, they do mention where they're at. Now, that is our BMS connector.
Okay.
Can you believe
Yes.
it took that much effort to get this out?
So you actually know what a BMS connector does, so.
That's how we're able to figure out the voltage.
Oh my god.
And the other reason why I want to get that out is we have to wire up the contactors. Not only can you access the BMS through it, so if we even wanted power to come out of the pack, you access the contactors inside of the pack. Yeah, it's a really easy one. Done.
Wait a minute, isn't that the same
This one
thing?
goes to the charger. Charger, inverter. This is the motor harness.
You know, I'm gonna keep all this here. In other words, all we're gonna do is detach what we don't need, correct?
Now we have to figure out which wire goes to what. We could split this.
I would not.
Yeah, I don't feel like that.
Nope, it's too nice together.
Okay, so just a bunch of continuity tests, I guess.
Yep.
So I unplugged the AWD connector off from the battery pack down here. Before, we just had some of these jumper wires plugged into there, and that's because we salvaged the battery connector from the old Nissan Leaf wiring harness that's over there. And this simply just kind of lines up, and then you twist it on, and that plugs everything in the way it's supposed to. However, we noticed that there's an issue. That when you slide this off, and you read from top down, it says right here, this top right pin is pin 1, and it says 1, 2, 3, 4, 5, and so on from right to left, like that. And also on the back of this, it says 5 here, 1 there, and so it goes 1, 2, 3, 4, 5. Reading it from that way, from left to right, top down. Now, this numbering is the same as what it says on the inside of the pins here. I can't take a photo that shows those pins because it's too close, but if we go over to the online diagram, this is from Dalla's battery emulator, so we're looking at the 2013 to 2023 model of the Nissan Leaf battery pack. However, if you notice something, it's mirrored. Pins 1 and 2 here are actually pins 4 and 5. So if we look at it like this, it's saying that these two, right, on this one it says it's 1, 2, but it's actually 1, 2. Now you might think, oh, that's correct, it's just that one line is incorrect, but he's reading it as if you're placing it like this, which is, this is actually pin 5 in the top right, which it says is pin 1. If you read it like this, now it's correct. Even though his numbers are wrong, it's the same, the pattern is correct as if you're looking from the outside of the connector, even though the OEM numbers are actually the other direction than this says. Just a note in case you go and try to do this yourself. We desheathed all of the motor wire harness that we unplugged. There's the inverter connector, here's the PDM connector. Notice the PDM connector is the same style connector as the BMS connector that goes here in front of the battery. So you can't mix these up. Also, we noticed one thing that was wrong on the diagram on this guy. If you read here, there's 8 rows here. On the diagram of how to wire the inverter connector, there's only 7. Note this is the 4th one down from the top, and it is the 4th one from the bottom. On the connector here, it's 5th down here, 4th up from the bottom, because as you can see there, you can count 4 down on that right side. There's nothing there. You can see it's 1 more down. So that's one error from this. Note pins 16 and 42 are connected here. In the original wiring harness, they're not connected, so don't expect that. However, the CAN lines that are in this guy and in this one are already linked together here. At the end of the loom here, you can see we have 2 sets of CAN lines. So we have our high-low here, and then we have one here, high-low as well. Since there's duplicates, we just pinned one down. But yeah, so there's pins 16 and 18, and then over here on this guy, it went to the original connector that went to the full wiring harness, and that's pins 29 and 30, and that's the proximity and charge port connectors. Here's the resolver connector that goes on the motor, and that does go back here to the inverter, but in the diagram, it doesn't show anything about rewiring that. So I don't know if we should plug that in or not. I assume we should so that the inverter knows where it's at. Additionally, this connector here, this side plate pops off with 2 screws. Note, this top connector isn't actually connected to anything. So you can just kind of push that in there, click it in. So you just take this, plug it in, twist it in. So now these are both in. So now let's wire that in. Let's grab one of these terminal blocks. That's why we have them. So okay, so here's our push button. That's our push button start. This is our key on, off, and then our forward, reverse, neutral. So now we need to figure out the CAN lines for the Leaf BMS go. Actually, we can't even do that yet. We can't do that yet because we haven't updated the firmware on the Zombie. Turn power back onto it. Connect to the Wi-Fi, done. Wait for this to refresh. So what I'm gonna do is I'm gonna go to update. Now there's a few different ways. What I wanted to use is the stm32_loader.bin file to update the bootloader on your OpenInverter board. You can download the file, the links in the forum here. I just did that. So what I'm gonna do is I'm gonna do firmware, install firmware from file. I'm gonna set this down on top of it, has its best likelihood of installing version 2.20.a. We're currently on version 2.17.a. Set it on top, load from file, files, bin. Okay, installing firmware. Update done. We can see we're on firmware null, so I'm gonna reboot the Zombieverter. Also note, I did this on my phone and not my laptop because it said that sometimes on a Windows machine it messes up. So let's do a reboot. Off, give it a second, turn it back on, and then there it is, ESP. I believe they changed the parameter list, so it's probably going to delete everything I had in my parameters list, which is fine for me. Do a refresh. Look at that. I got an error. Number 6, stop for pre-charge. Yep, and you can see right there, 2.20.a. So good. We have updated successfully, and it knows that there is, in fact, an issue. So let's go to parameters. Oh, it kept it, actually. We got a stop code called pre-charge. That's still there. Here, let me go to spot values. Oh, yeah, it's pre-charge fail. Charge type AC. Why is it trying to charge? That's weird. Well, let's set it into start mode. Interesting, it's trying to charge. Huh. Status UDC below UDC something pot pressed. Now, on, relay click, connected. Okay, no, it gave us the same error. Stop pre-charge. Oh, now it says it's off. Now it went back to pre-charge fail. Huh, okay, so obviously we have something not connected. Can you tell?
I think it's right there.
I've gone through the settings and I realized that the error I was getting was UDC below UDC switch pot pressed. Go back. I realized that the UDC minimum is 450 volts. Our pack currently isn't at 450 volts. So just for the sake of this, I'm gonna set this to 300 and see if that fixes anything. Oh, pre-charge stop. Oh, I'm kinda done for now. Now that we got battery thing off here, let's connect that up. We need the connectors for the brake pedal and gas pedal. Okay, the connector looks fine. Yeah, so now we need to make sure that those contactors are actually clicking. Right now, what we want to see is across this contactor here. Should be absolutely nothing. Battery pack is off, both contactors are off, yeah, nothing. So if we change this to continuity, this should still be off, which it is. Okay, good. So that means now that if we grab our harness, plug that in, we have the color code diagram. These should be our contactors. Put that onto there, hide it in sheathing. Now, when I apply ground and 12 volts to one of these, that should click that first one. So that's that contactor. Yellow, positive contactor. So that's the right post, is that first incoming. Take these off now. Put those caps back on. Take off the secondary caps. So this one should be our negative, and negative with blue. So this blue one should be the contactor now. And it was indeed. Okay, and that means that green now should be the third contactor for pre-charge, which honestly, I don't know where that is. I see the main two right here, but I don't see where the third one is. 6 wires here plugging into this distribution block. So I guess somewhere underneath one of these contactors is another smaller one. I guess it doesn't need to be bigger because you only have it on when you first boot this, right? So that was what?
Green.
Yeah, it's a way quieter of a sound. Okay, so just for sake of effect, set it to 1000. Plug this into the end terminals now. If I connect these two, both of them at the same time, then this should read the 382 volts, if I remember that right. So I'll click one, you'll hear one click, and then nothing will read. I'll click the second one, and then it'll read, because you have to have both sides to have connection. So one is gonna happen now. The second one.
It was like 07.
I have a feeling this might be a multimeter thing, otherwise we have an issue. Let me just test the multimeter, see if I didn't like fry it somehow. Uh-oh.
What do you have it set for?
Continuity.
Put it on the 12 volts. So.
I was reading that right. Oh, that's really weird. That was not measuring it there before. Okay, well, what I'm more confused about is that we've read across these terminals before and not had an issue. Like if I read from here to here, look at that, that's, yeah, 380 volts right there. So why the heck, if we went through the contactor, is it now having an upset day?
Oh, maybe your little alligator clips can't handle.
That shouldn't be the case. Yeah, but there's no amperage. You have to remember when you read voltage through a multimeter, the resistance is super duper duper high. My only thought would be maybe that these alligator clips didn't have a good connection. Okay, let's just try it one more time. One in, should be nothing. And then second one in, there it is. Yeah, 380. Okay, so battery pack is working as it should. For some reason, Zombieverter wasn't triggering this correctly, and that's probably due to, once again, alligator clips. So now, before we clip on that, we need to connect everything up to the motor.
Yes, we gotta pull it out.
Since this thing doesn't have the actual cylinder behind it, we need something to keep this thing from falling down. Okay, that's brake pedal, and that's gas pedal. First is opening up the laptop and having the ESP module connect to the laptop. A little worrisome. We'll wait for it to find that. Let's just double check. At 12.3 volts, exactly what we should be getting. Here's the ESP, connect, load the interface. Cool, no error. Dashboard, no errors, parameters. Plug this in real quick. There we go. Let's plug back in. Okay, no errors. Go into parameters. Gen 1, vehicle, none, gear type, none. Transmission manual, charge modes, Leaf PDM, BMS mode, Leaf BMS. Shunt type, that's supposed to be none because it's Leaf BMS. Inverter is on CAN 1, the vehicle is CAN 1. Shunt, which I'm assuming they're talking about the Leaf BMS, is CAN 2. We're not doing Lin CAN. Charger CAN is on 1, BMS is on CAN 2. Throttle, so we have a min and a max for 1 and 2. Okay, so operation mode, we're in off. Where is throttle? I found it. Okay, so right now if I full throttle, then off throttle. So
added and subtracted
yeah.
10 on each direction.
I was gonna say, let's do 180 and 330. Let's go back our spot values. Let's go all the way up. Max throttle, 800 basically, and 2000. So we'll say that max is 780 and 1970. Potentiometer is dual channel. Save that real quick. Direction mode is on a switch, it's not reversed. And it's charger stuff, which we're not touching on. DC to DC. I believe it's for a Leaf, it's hardwired, so it's not in here. General purpose, we're not gonna do any of that. I do like the tachometer option though. Okay, so everything is set. Go back to dashboard, no errors. So let's turn on our power switch. Still in off state. Okay, so it's now saying it's doing pre-charge. I don't hear any contactors yet. Pre-charge fail. When it comes to these contactors, we have our ground in and then our positive rail on the other side. Oh? Okay, so say we have wires 31, 33, and 34 to our contactors, right? It shows them going to the contactors, and then out of the contactor is a red wire going to 12 volts. Ours is going to ground. We assume that the 12 volts comes out of here. This acts as the ground, not the source. AKA, we're putting both terminals on ground. That explains why we have separate grounds. The only issue that I'm having with this now, though, is that 3 of these go to these contactors. Which 3 of these go to those contactors? Because our ground needs to be moved to our 12 volt line. Now, do you see the dilemma?
They're not really grounds. They're power source.
Yeah, which is 12 volt line. How did we miss that? I guess it's because in this diagram here,
it shows them as grounds.
Yeah, it shows them as grounds, and that all goes to ground.
It says it, black, ground, 1, 2, 3.
Yeah,
4,
but
5,
you know what
6.
we didn't say? This is positive. But I guess we assumed that meant that that was coming from the Zombieverter, but I guess this is a whole different project, technically. So, they're contactors, right? You can technically power them in either order, right? It's just a relay in the end of the day. It's a big relay. So, do we leave our color-coded ones with the Zombieverter and trying to find the ground and move it to 12 volt? Yeah, I don't want to put any of the grounds on 12 volts, but also at the same time, these are how we know which one is going to that. I don't like that. We know which one is ground from the diagram. So now we're gonna go back to spot values. Okay.
Oh my God.
Okay, we just heard the click. Hey, we're in run mode. Oh, we are in run mode. Oh, wait, hold up. We're in run mode. Oh, and regen works too.
Regen's on. Okay, reverse.
Yeah.
Maybe that's neutral.
Oh, it said the throttle sensors were too different. Remember I said it turns off if they're too different?
Yes. It's leaking. Oh, it's oil coming out.
It's not oil, it's water. Okay,
Water.
well.
She runs! She runs!
Okay, why the heck did it just do that?
I don't know. It jumped. It power surged.
It's an off. It's an off.
Good catch, by the way.
Yeah, by the way, all I had was this. I had 3 fingers on there on that little ledge. I'm surprised. That thing, how far did this thing go over? Oh, actually.
Oh, look at that.
Okay, yeah, this is super imbalanced. We can't.
Can we bolt it down?
Yeah, let's get some ratchet straps.
And we'll slide it back into that little, here.
There we go.
We slide it back into here in case it does go. Should be plenty of cable. Perfect. Just do the first setting, what you had before. Click, click, all 3 went.
I have a feeling that I set up the resistance values for this wrong. I don't think I gave enough wiggle room.
Okay.
Okay.
Beautiful brake.
Put in reverse.
This is when it jumped. Nothing happened.
Something's weird with reverse. Yeah, reverse has got something weird with it. It's a little too jumpy for reverse. You have to remember, there's a giant rotor in there spinning with that. So now we just heard the contactors click off. What's just a piece of tape? We can put it on there. We can watch it spin.
Here's the duct tape. Here.
Everything is off. Just get a piece of tape, do a little bit of visualization. We hit on, then we hit run. Heard the contactors click. Wow, that brake is super touchy. We're gonna have to change that. But then again, we don't have any like rotating mass on this. So. Wow, that's just a hair. We have to change that max speed. Okay, well there we go. Very nice. So this is our test board right now. We have a bunch of screw terminals mounted in here. We have our 5 grounds from the battery pack, and then these other 3 ground looking wires are originally Nissan Leaf ground wires to the contactors. Now, on Dala's battery emulator wiring diagram for his board, you use these as ground, so you have them wired up the ground. And I didn't really question that when it came to the Leaf, just because things are pretty much wired the same. You have the same 3 type of wires for pre-charge, negative and positive contactors that go to the Zombieverter that's up there. Now, what I didn't realize is that for the LilyGo board for Dala's battery emulator, that these wires are ground, and these over here are positive. For the Zombieverter, it's the other way around. These grounds are used as positive, and these 3 wires are used as your negative. Now it really confused me because these 3 wires that are labeled in the diagram for the Zombieverter, you know, they're color coded so you know which one which goes to the Zombieverter. Yet the ones that are all the same are the positive, which are black. So that's why our contactors weren't originally tripping, was because we were giving it a ground on the positive and a ground on the negative side, which obviously won't power a contactor. And since contactors contactors are, it's an inductor, you can power them both ways. It doesn't matter which way is positive and negative. We chose to leave the colorful ones as the ones that are labeled to the Zombieverter so we don't accidentally mix those up, because that could lead to the contactors welding themselves. So we have a whole separate block for positive for just the contactor, then all universal ground, all positive, and then this guy up here is our switched 12 volts. So this guy right here, which could be replaced for a key, it's not a momentary switch, it's a on or off position stationary switch, same as this one. So when you press this, that turns on this bar right here, and that turns on the Leaf BMS. It sends a signal over to the Zombieverter saying, hey, that this switch has been pushed. Over here is our relay for our charger and inverter 12 volt power. That way, so that can switch those on. Over here we have our forward neutral reverse switch. Well, technically it's just a forward reverse switch because neutral is, well, whenever there's no throttle on an electric car. And then up here we have our momentary run switch. So basically, if you had a key and you hit on, that's like pushing that button. And then when you push it a little bit further and it springs back, that's like pushing that button, puts into the run state until you turn it off, which would be like clicking that again. Pushing this for some reason does nothing. So there's, you know, you can't start your car once it's already started. So there's that. These boards right here are just breakout boards from our connectors in, and then this is our positive 12 volts and our ground. And that all leads up to the Zombieverter. Just note the ground and positive 12 volts for the contactors are different between the battery emulator and the Zombieverter. And for safety reasons, I added a big 120 20 amp switch on here. So if we put across where our 12 volts is supposed to be, we can see on our multimeter, nothing. So when we are testing and rewiring, we can easily switch that off. That's our emergency kill switch. So this is essentially all 12 volts, except for obviously the CAN lines, which are a lower level thing. But the throttle pedal is 5 volts. So we have it on the separate color coding from the rest of the wiring. And believe it or not, our signal wires here are the red wires and not the white or black. So black is ground, white is 5 volt, and the red is our signal. So we're keeping that off the board just to disassociate it from everything else. The brake, however, is 12 volts because that's just a switch on or off signal, while this is a potentiometer or dual potentiometer value. So I'm going to push the on button. You didn't hear anything because there was nothing to hear. When I press this run button right now, we're going to see the operation mode change the run, and this relay right here is going to click. I'm going to set the microphone right here so you can hear it. So you heard that click, and at the same time, and that's basically about it. You heard those about 3 clicks, because remember, we have 3 contactors. We have our positive, negative, and pre-charge. And when we do our startup, we have our negative contactor and our pre-charge contactor connect at the same time. That way, so we have a complete loop, and that pre-charge is a contactor that goes through a resistor. So then we turn on our positive contactor and then turn off pre-charge. That way, so we have both contactors, no resistor going through the battery pack. That way, so there's no rush surge current to the charger or to the inverter. So now while it's still running and the contactors are still on, if I press the throttle pedal, there are 2 potentiometers in here, and if they're increasing by the same ratio, considering their different resistance values, the Zombieverter will consider that an okay throttle input. If the 2 resistance values don't increase at the same scale or at the same ratio, then it will consider it an invalid input and it won't spin the motor. Since this is going to read it correctly right now, the Zombieverter is going to give a command to the inverter to spin the motor. And it's going to keep on spinning basically until it either spins all the way down or I apply the brake through regen and see it spins down. Since there's like no flywheel on any of this, when I apply the regen, there's going to be such a large braking force, it's going to start rotating in the opposite direction. That's clockwise, and if I brake it, the counterclockwise. And so now if I just want to turn it off, you can go back and hit the off button, which is turning your key back to the normal position. This is what it sounds like when you turn off the battery pack. There we go. So we heard one contactor turn off, and then we heard the second contactor turn off. I don't know why they don't do them at the same time. There's probably some logic to it. It's probably so you don't like pull both battery terminals off at the same time and cause 2 sparks. Maybe it makes sure that if one dies, you always have the second one to back up, to turn off. It's probably a safety thing, something like that. But regardless, it's 2 separate clicks about a second and a half apart. So now all the contactors inside the battery pack have now turned off, and there's no power being sent from the battery pack to the charger, inverter, or the DC charger. You may be wondering, wait, there's charging right now. So let's look at this multimeter. If I take off this rubber boot here and I touch on the positive 12 and the ground, we're gonna see, basically 12.5 volts. So now if you could hit the power button, so this is like turning the key, nothing's gonna happen. Now press the run button real quick so I can turn on the battery pack. Now you just saw it jump up to basically 14.5 volts. Why did that happen? Well, that's because now that this charger has the whole 380 volts coming into it, it sees that battery down there and it's gonna send the command to start charging through these 2 connectors. It basically charges the battery battery from the bigger battery. So about 400 volts down to 12 volts. That way, so your 12 volt battery is always topped up. You don't have to worry about it dying. Obviously, this only happens when the car is on. So if you leave your car for an extended amount of time and leave accessories running, blah, 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 that battery will die and you have to recharge it yourself, because you won't be able to get the contactors on if it's too low. Obviously, contactors don't take that much power, so clicking it on won't be that terribly difficult, but still it might happen. But it's nice that we have DC to DC. So basically now that we have the wiring temporarily complete, the Zombieverter is communicating properly, the charger is connected to the battery is responding correctly, the contactors are opening at the right time, and we're actually getting communication enough to make the motor spin and the DC to DC charging from the charger to the 12 volt battery. That's the basics done. The next step would be getting the Leaf PDM charger connected to like 110, 220. So either I'm gonna do that in the next video, or I'm gonna get impatient to do a bit of a side quest with this. AKA, I'm gonna put this in something that's not a go-kart for one video just to have some fun with it. And I'm gonna give you a hint. 20 payments of $19.99. And I'll give you another hint. It was a household kitchen appliance. Anyway, thank you for watching. I'll leave it at this.